Hey, good day everyone. Welcome back to my channel. Now, in this video, we shall be looking at chemistry titration, NECO precisely. So, in this lesson, I'm going to teach you how to perform titration, the approach to titration question precisely, without stressing yourself with a lot of titrations or even without any titration. Now, what the examiner will mark is what you have in your booklet. We are not advanced to the extent that the camera will be somewhere watching you how you perform that experiment. No, but what is in your booklet, is what the examiner will mark. So you should be able to perform an answer question very fast within few minutes, and you go to the next question. So this video will teach us how to approach question with respect to titration. Now, this is a question. It says A is a solution containing 5.30 gram per dm cube solution of H2SO4, B is a solution of unknown concentration of Na2CO3. Okay, that is sodium triazocarbonate 4. This is tetrasulfate acid. Then we've been asked to put A in the burette and titrate against 20 cm cube or 25 cm cube portion of B using methyl orange as the indicator. Alright, so now what does that mean? We have to put our acid H2SO4 in a burette to the 0 or 50 centimeter mark, and then we titrate against 20 cm cube or 25 cm cube portion of B. So it depends on the pipette you are given in your school to know the volume of your base. Okay, it could be 20, it could be 25, but 25 is most common. Okay, so using methyl orange as the indicator, then record the volume of the pipette. So you should record the volume of your pipette that you use, either 25 or 20. Then said you should tabulate say you should tabulate your burette reading and calculate the average volume of acid used. Okay, you should tabulate your burette reading and calculate the average volume of acid used. So now in this kind of approach, to answer these parts of the question, our acid is already in the burette, we have pipetted, then we have added 2 or 3 drops of the methyl orange, then we mix this the methyl orange at the base, then we place it under the pipette for proper titration. We've done that. We've seen the color change. Okay, so having noted the color change, we write, then let's solve solution to the A part of that question. Yeah, so now what do? We are asked to record the volume of our pipettes. So the pipette is 25 cm cube. Now, so the next thing now is the table of results. So you have to draw your table, and the table has the burette reading. You have the initial burette reading, the final burette reading, then the volume of acid used, and your first titration, the second titration, and then the third titration. So you can do 2 titration, and if you decide to do 3 titration, so whichever titration you are doing, just make sure you note and choose the best answer. Okay, not necessarily you choose all the 3 answers, the 3 titrations. You can just use 2, and then you will find the average volume of the acid used. Now, in doing this, in my first titration, starting from the 0 mark, okay, that's the initial burette reading. So when we do the first titration and the end point happens to be 18.60, then I use that as I use the final the final burette reading in my first titration as my initial for the second titration, okay, without refilling the burette. So then my endpoint for the second titration, starting with the 18.60 for the first titration, was 17.10. okay, so now I quickly fill my burette to the 0 mark again. So and I start my initial at 0.0 and my endpoint happens to be 18.51. So now I will have to quickly calculate the volume of the acid used by subtracting this from this. So for the first titration, I have 18.61. Then for the second titration, when I subtracted this from this, so I have 18.50. And then for this one, the third titration, I have 18.51. okay, so now from the volume of acid used, I can see that this result and this result are very close. So the difference between them is 0.1, which is very far from the first titration. So I'm going to neglect this first titration. I will use these two because their values are very close. Okay, so when the value is above 0.2 marks between different titrations, so you choose the one within the range of 0.2. But if it is far above that, so you won't use. So the average volume of acid used will therefore be equal to, I'm using the second titer and also using the third titer over 2. Okay, so what does that mean? That is 18.51 plus 18.50 for the second plus 18.51 divided by 2. Please, your steps are very, very essential for the examiner to mark. So you have to write out every step. So easy. So it will be, so you can have your marks. So that is 37.01 divided by 2. So when we divide that by 2, we got, that is 37.01 divided by 2, and that is 18.505. So which we can approximate, or we don't approximate, just leave it like that, cm cube. That is the volume of acid used. We don't approximate the volume yet. Now we calculated the volume of acid used as the instruction. So now we have tabulated our burette reading and calculated the volume of acid used. Now from the next question says, from your results and information provided, we should calculate the concentration of A in mole per dm cube. That is B Roman figure 1. B Roman figure 1. Question B Roman figure 1. We should calculate concentration of A in moles per dm cube. All right. Now, are we given any value of A from the beginning? Yeah, at the beginning of the question, we are told that the A is a solution containing 5.30 gram. So which is the mass conc? This is the concentration in gram per dm cube. That's the mass conc. So we know that mass concentration is equal to the molar concentration multiplied by the molar mass. So, but meanwhile, we are asked to calculate the molar concentration, which is the mole per dm cube. So to get the molar conc, that will be equal to mass concentration over the molar mass. So now the mass concentration is 5.30. Then the molar mass of your acid H2SO4, hydrogen is 1 multiplied by 2 plus 32, that's 34 plus 16 times 4, that is 64 plus 34, that is 98. Okay, so 5.30 divided by 98. So 5.30 divided by 98, that is 0.0541. Approximately mole per dm cube. So that is the concentration in moles per dm cube of A. Now the Roman figure 2 part of question B, what does it say? It says calculate the concentration of B in mole per dm cube. All right, so also concentration of B in moles per dm cube. So how do we approach that? The concentration of B. Now we've been given B. The B is a solution of unknown concentration of Na2CO3. Okay, so the concentration of B is not known, so we have to calculate the concentration of B. So to get the concentration of B in mole per dm cube, we have the concentration of A to be 0.0541. We don't know the concentration of B. We have been asked to calculate that. Okay, now the volume of B is 25. That's the volume of the pipette, and the volume of A has been calculated to be 18.505 cm cube. Now I think we were given the equation of reaction here. Okay, balanced equation is balanced. Now the volume, the number of mole of acid is 1, and the number of mole of our base is also 1. So Na is 1, and then Mb is also 1. So now using the general equation of our titration, we have CAVA over CB VB equal to Na over Mb. So you can write and tell the examiner, let the examiner know that your Ca is the concentration of acid, Va is volume of acid, Cb is concentration of base, Vb is volume of base, Na is number of mole of acid, Mb is number of mole of base. So now, having done that, we know the concentration of acid to be 0.0541 multiplied by the volume of acid, that is 18.505 divided by concentration of base is what we've been asked to calculate, multiplied by volume of base is 25, equal to 1/1. Okay, now having done that, we can multiply 0.0541 multiplied by 18.505. And what do we get? So we got 1.001. over CB multiplied by 25 equal to 1/1. Then we can cross multiply. We have our CB times 25 equal to 1.0011205. Then we divide both sides by 25. I decided not to approximate at this point, so this will cancel this. Then our concentration of base will therefore be that value divided by 25, so which is 0.04 mole per dm cube. So concentration of base, concentration of B in moles per dm cube is equal to 0.04 mole per dm cube. Okay, we go to the third Roman figure 3 of the question. Now what does it say? It says we should calculate the concentration of B in gram per dm cube. Concentration of B in gram per dm cube in gram per dm cube. We've calculated this concentration in mole per dm cube, and we need to calculate its concentration in gram per dm cube, so which is the mass concentration. So, and we've written that mass concentration is equal to molar concentration multiplied by the molar mass. So the molar concentration, that is concentration in mole per dm cube, okay, which is 0.04 multiplied by molar mass of Na2CO3, which is B. Molar mass of B has been calculated to be 106. So when you multiply 0.04 multiplied by 106, what do we have? So meaning that is equal to 4.24 gram per dm cube. So that the concentration in gram per dm cube of B is equal to 4.24 gram per dm cube. Then the fourth Roman figure there, what does it say? What's the question? So we should calculate the amount in moles of the acid in the average titer. The amount in moles of the acid in the average titer. Amount in moles of H2SO4 in the average titer. So we have that Amount in mole is equal to concentration multiplied by the volume, okay, in dm cube. Alright, so the concentration of acid we calculated to be 0.0541. Concentration in mole per dm cube of the acid is 0.0541. Excuse me. Multiplied by the volume of the acid in the average titer, which is the average titer of acid, the average titer of acid use. We come back here, okay, which is 18.505. 18.505. We have to divide by 1000, okay, to convert it to dm cube. So what do we have? We have 0.0541 multiplied by 18.050, okay, divided by 1000. All right, that is the number of mole is equal to 0.0011 moles of acid, okay. So that is the amount in moles. That is the amount in moles of the acid used. Then Roman figure 5, what does it say? Roman figure 5, what does it say? It says we should calculate the amount in mole of the volume of B pipetted. Amount in moles of let me see the question again. Of volume of the amount in mole in the volume of B pipetted, rather. Amount in mole of B pipetted. Okay, so now the same thing, the same approach. Number of mole is equal to concentration times volume, and number of mole, the concentration of B in mole per dm cube has been calculated, which is 0.04. 0.04 multiplied by the volume of B titrated 25, also divided by 1000. So that is 0.04 multiplied by 25, that is 1, divided by 1000, okay, which is equal to 0.001. All right, so moles.